Hello guys, I'm Sam. Today we'll dive into circle geometry, covering key concepts, theorems, and examples tailored for learners who are doing grade 11 and grade 12. For you to be able to master this topic, you need to know what is the radius, diameter, and a chord. So let's start with the radius. Radius is the line that connects the center of a circle to any point on the circle's circumference. Diameter is the line that connects 2 points on the circumference. It passes through the center. Chord. A chord is the line that connects 2 points on the circumference. It does not necessarily pass through the center. As you can see, the circle we are given that O is the center. OA is the radius. OB is also the radius. So what you're going to write in the exam, you're going to write OA is equals to OB. And the reason will be radii. Radii is the plural form of radius. BE is the diameter. Therefore, diameter is equals to 2 times the radius. Then let me show you the picture of the chord. Yeah, that is the picture of the chord. AB is the chord. Remember that a chord is the line that connects 2 points on the circumference. It does not necessarily pass through the center. Let's dive into theorems. Theorem number 1. Line drawn from the center of the circle perpendicular to the chord bisects the chord. This theorem means that whenever you see the line drawn from the center going to form 90 degrees angle on the chord, just know that that particular line bisects the chord. It divides the chord into 2 equal parts. Here we're given that O is the center and E2 is equals to 90 degrees. Line OE drawn from the center forms 90 degrees angle on the chord AU. That's why we got AE is equals to EU. And the reason is line from center perpendicular to the chord. Line OE drawn from the center divided the chord into 2 equal parts since it is perpendicular to the chord. Let's move to theorem 2. Line drawn from the center of the circle bisecting the chord is perpendicular to the chord. This theorem means that whenever you see the line drawn from the center of the circle going to bisect the chord or going to midpoint the chord or going to divide the chord into 2 equal parts, that particular line is perpendicular to the chord. Yeah, here's the picture of what I'm talking about. We're given that O is the center and A is equals to EU. Line OE drawn from the center bisects the chord AU. That's what we got. OEU is equals to OEA is equals to 90 degrees. And the reason is line from the center bisecting the chord. That is the reason you are going to write in your exams. Since OE forms 90 degrees angle on AU, OE is perpendicular to the chord AU. Let's move to another theorem. Theorem 3. A diameter of a circle subtends right angle on the circle. This means a diameter always forms a right angle with the circle's circumference. Another can say any angle subtended by a diameter at the circumference is 90 degrees. Here we are given that O is the center. BC is the diameter. As I said, a diameter it is the line that connects 2 points on the circle circumference, and it is the line that passes through the center. So BC it is the diameter. Diameter BC will form 90 degrees angle on A. So that's why we got A as is equals to 90 degrees. And the reason that we're gonna give in our exams will be angle on a semicircle. Theorem 4. Angle at center is 2 times angle at circumference, only when they are subtended by the same chord or arc. So, angle at the center will be 2 times angle at circumference, only when they are subtended by the same chord or arc. One cannot help but be struck by the sheer simplicity of this theorem. It is very easy to be understood. But let's be on the safe side by looking at this. Here we're given that O is the center. Wait, I forgot to tell you that theorem 4 has three cases. So let's start with case 1. Here we're given that O is the center. We can see that EU subtends angle at the center, subtends angle O1 at the center, and also subtends angle A at the circumference. So angle O1 that is at the center will be equals to 2 times angle A that is at the circumference, and the reason will be angle at the center is equals to 2 times angle at circumference. Case 2 of theorem 4. We are given that O is the center. BC subtends angle at the center O and also subtends angle at the circumference, and that angle is A. So angle O will be equal to 2 times angle A, and the reason will be angle at center is equal to 2 times angle at circumference. Case 3 of theorem 4. We are given that O is the center. BC subtends angle at the center, subtends angle O1 at the center, and also subtends angle A at the circumference. So angle at center will be 2 times angle at the circumference since they are subtended by the same chord or arc. So angle O1 will be equal to 2 times angle A, and the reason will be angle at center is 2 times angle at circumference. Theorem 5. The opposite angles of cyclic quadrilateral are supplementary. In bracket is equals to 180 degrees. What you must know is that two angles are supplementary if their sum is equal to 180 degrees. So the sum of the opposite angles of cyclic quadrilateral will always be 180 degrees. Don't let it slip your mind. Here we're given that O is the center. AEUI is the cyclic quad. Even though we are not told that it is the cyclic quad, we all can see that all 4 vertices of the quadrilateral lie on the circle's circumference. That's why I say it is the cyclic quad. So when you are in exams, you find a question where the examiner did not mention that some quadrilateral it is the cyclic quad, but you can see that all 4 vertices of the cyclic quad lie on the circle circumference. Don't get confused. Just treat that quadrilateral as the cyclic quad. Do not wait for the examiner to tell you that some quadrilateral it is the cyclic quad. Yeah, so remember that opposite angles of a cyclic quad are supplementary. That's why we have our angle A plus angle U as equals to 180 degrees, and the reason is opposite angles of a cyclic quad. Angle E plus angle I is equals to 180 degrees, as in opposite angles of the cyclic quad. So if we were given that angle A is equals to 75 degrees, we're going to say angle A plus angle U is equals to 180 degrees, and the reason will be opposite angles of a cyclic quad. Then we're going to substitute angle A, and we're going to say 180 degrees minus 75. Our angle U will be 105 degrees. Let's move to theorem 6. Exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of a cyclic quadrilateral. The lucidity of this theorem is striking, but let me explain it in a way that is totally over the top. Yeah, look at this. Angle U1 is the exterior angle, and one can ask, which angle will be equal to the angle U1? The opposite interior angle of a cyclic quad will be equal to angle U1, since angle U1 is the exterior angle of a cyclic quad. Let me show you how to find the opposite interior angle of a cyclic quad. So the first step, we're gonna put the dot on the vertex that is close to the exterior angle. Second step, you'll draw the straight line that goes to the opposite vertex. You can see that that line goes straight to angle A, which means angle U1 is equal to angle A. Theorem 7. Angles on a circle that are subtended by the same arc or chord are equal. So angles that are subtended by the same arc or chord will be equal. Let me break it down for you. Look at this. I'll teach you how to find angles that are subtended by the same arc or chord. First, let's focus on EU and check angles that are subtended by EU. But how to do that? How to find angles that are subtended by EU? First step, put your index fingers on E and U. Second step, check lines that will enable you to move your fingers along. I see line UA and line EA. So let's move our index fingers along those lines. There we have our angle A. Then let's check another angle that is equals to A. We'll put our index fingers on E and U and check different lines. We'll be able to move our fingers along. I see line EI and line UI. Let's move our fingers along those lines. There we have our angle I. Therefore, angle A is equal to angle I, and the reason is angles in same segment. And now let's focus on AI. To find angles that AI subtends, we'll follow steps that we have done when we were dealing with EU. With this one, we'll find that angle E is equal to angle U, and the reason will be angles in same segment. We are done with theorem 7. Before we move to theorem 8, you'll need to know the difference between a secant and a tangent. So let's look at the definition of a secant. Secant. A secant is the line that touches a circle at two different points. Let me do it for you. Yeah, AB is the secant. Since a secant is the line that touches a circle at two different points. Tangent. A tangent is the line that touches a circle at only one point. Let me draw it for you. Yeah, that is the picture of the tangent. AB is the tangent. Since a tangent is the line that touches a circle at only one point. Theorem 8, which is tan-chord theorem. Angle between the tangent and the chord is equal to the angle in the alternate segment. Let me break it down for you. When a tangent and a chord intersect on a circle, they form an angle. The angle formed is equal to the angle in the alternate segment, which is the segment on the opposite side of the circle from the angle that is between a tangent and a chord. Let me show you the easy way of finding the angle that is equal to the angle between the tangent and the chord. Just put your index fingers on the chord, then move them along lines that lead you to an angle that is on the circumference. Then you'll see which angle is equal to the angle between the tangent and the chord. On this one, angle EUP is equal to angle A, and the reason is tan-chord theorem. Theorem 9. A tangent to a circle is perpendicular to the radius at a point of contact. This theorem means where a tangent and a radius intersect, we find 90 degrees angle. Look at this. O is the center, OA is the radius, BC is the tangent. Radius and a tangent intersect at A. That's why A1 is equal to A2 is equal to 90 degrees, and the reason is radius perpendicular to tangent. Theorem 10. Two tangents drawn to a circle from the same point outside the circle are equal in length. This theorem means if you draw two tangents from the same point outside the circle, they will be equal in length, regardless of the direction they are drawing. Here we have our AB is equals to CB, and the reason is tangents from the same point. The point that we are talking about is point B. Theorem 11. Equal chords subtend equal angles at the center and at the circumference. This theorem means if two chords in a circle have the same length, they will form equal angles at the center and at the circumference. The equality of angles holds true regardless of where the chords are located in the circle. Here we have center O, BC is equals to DF. Since BC is equals to DF, they will subtend equal angles at the center and at the circumference. Angle A is equals to angle E, and the reason is equal chords is equals to equal angles. At the center, angle O is equals to angle O3, and the reason is equal chords is equals to equal angles. We are done with circle theorems. Thanks guys for your time. Please subscribe on my YouTube channel and don't forget to like this video.